I have to say, I am bloody impressed with that. That is remarkable. Is there a way that we could give it a deliberately difficult problem?
If you failed to renegotiate
more American troops
Hillary
in Iraq,
Clinton,
you can
Hillary
propose
Clinton,
that.
Hillary Clinton failed to renegotiate the status of forces agreement.
No, that is incorrect.
And so we removed all of our troops from Iraq, and ISIS was able to be conjured up in that vacuum
But I'd like to
and overrun vast areas of Iraq.
It's done okay there.
I'm very impressed with that.
Oh yeah, it's quite impressive, isn't it, Tim?
All right, thanks.
Yes, it is Humphrey.
That'll do.
It's really cool. Wow. Demos never work first time.
It's how the conversation flows. It's what it's able to do for you. That's the bottleneck. Latency is, I mean, it has to be low enough, but I think it's better to have a much more consistent experience where you know there's a bit of a pause. Otherwise, it can become quite chaotic. One of the things that we want to do is understand every voice. This is our vision, it's our mission. We want to execute against that. We take it seriously. And part of that means that we want to recognize underrepresented people, be as inclusive as we can, whilst recognizing that the training distribution is not always going to cover everyone we'd love it to.
So which LLM are you using for that? Will is from Speechmatics, and I'm very excited about this because I've been a customer myself of Speechmatics for many years. All of the captions that you read on MLST have been transcribed by Speechmatics for the last 2 years. I built a startup called X-Ray, which is a speech transcription startup, which is using Speechmatics behind the scenes. And here I am in your offices speaking with you in person. It's an honor, Will. So thank you so much for coming on.
Yeah, thanks for having me. I'm looking forward to our discussion.
So what do you do at Speechmatics?
I'm a CTO. I've had various different, almost all different roles in the engineering team since I joined as an intern. But today I'm heading up our engineering team. Speechmatics is a speech-to-text API. Now, no longer just that. We do real-time translation and offer some kind of LLM-powered APIs on top of our speech transcription output. But that's our bread and butter, is to do transcription, both batch and real-time.
So diarization is when an algorithm can kind of figure out the boundaries between different speakers, and that's something that your service supports. What's your current thinking around diarization?
Diarization is a tough problem. It's probably tougher than ASR, and I think it's slightly maybe underrepresented as a problem in general. I think it's something that we should be able to solve with current tech fairly well. We can embed speakers. We should be able to differentiate them, but there's lots of issues with acoustic environments sort of affecting those embeddings. But yeah, we're really pushing hard for big advances in diarization internally. Ultimately, there's extra information in the ASR that you want to exploit. You've got the words, and so that there's a lot of signal there, and so whatever system you have ultimately should be exploiting that information.
It is a cool idea, because why shouldn't it be able to do it, right? It should be able to automatically ascertain that that's David Chalmers.
Yep.
But the reality is it's brittle.
Yeah. Well, I've got a demo actually which shows that working.
Oh, have you?
Yeah.
Do you want to show us?
Yeah.
So you do automated diarization labels?
This is our new conversational assistant.
Oh, okay.
It should be able to infer who's who.
Oh, that's amazing.
And automatically kind of pick it up and start using your name and so on.
Oh, wow.
This is our new conversational assistant called Flo. We've got a chap called Humphrey.
Hello, I'm Humphrey. Nice to meet you.
Hi, my name's Will. How's it going?
Will, nice one. I'm doing all right, thanks. How about you then?
Yeah, all right, thanks. I'm here with Tim from Machine Learning Street Talk. Perhaps he can introduce himself.
Oh, hey, how's it going, Humphrey? It's lovely to meet you.
Nice to meet you too. Tim, thanks for introducing yourself. So what brings you two here today then?
Well, we wanted to talk about some of the finer points of machine learning.
Oh, fascinating. I'm not exactly an expert, but I'm happy to learn. What specific aspects of machine learning were you looking to discuss?
Well, before we dive into that, could you just tell me who's with me in the room?
There's you, Will and Tim from Machine Learning Street Talk. And then there's me, Humphrey. That's the three of us, I think.
Oh, that's brilliant. And who am I?
You're Tim from Machine Learning Street Talk, if I'm not mistaken.
No, you're not mistaken. This is Tim.
Oh, good. Just making sure, Tim.
That's brilliant.
This might not go down as the world's best demo, but it does work.
Yeah, that's amazing. So it actually knows on the the embedding that it's me.
Yeah.
Wow.
Oh yeah, it's quite impressive, isn't it, Tim?
All right. Thanks,
Yes, it is Humphrey.
Yeah, that'll do.
It's really cool. Wow. Demos never work first time. That's really good.
That's good.
So which LLM are you using for that?
You know, I don't know. It's either Llama or it's Llama or GPT-4.
Llama 3 or GPT-4.
Llama 3. Yeah.
Yeah, so are you doing like an intermediate transcription and then sticking it to the LLM? Yeah. The latency wasn't too bad.
Yeah, latency is fine. So this is the thing about Moshi, was they're saying latency is a bottleneck. We need it at 300 milliseconds or whatever.
Yeah.
It's not the bottleneck at all. It's the actual intelligence of the conversation. It's how the conversation flows. It's what it's able to do for you. That's the bottleneck. Latency is, I mean, it has to be low enough, but I think it's better to have a much more consistent experience where you know there's a bit of a pause. Otherwise, it can become quite chaotic.
The thing is, the problem you've solved, and I know this problem because I've implemented the same system myself, is during TTS you have to turn the mic off because otherwise the TTS would feed back into the mic.
We have a few heuristics in there as well.
And that's why I think the only way to really solve that problem, and maybe you're proving me wrong, I assumed was to have a bidirectional model.
Yeah, I think we need bidirectional models ultimately, but like this is good enough. And this gets you the performance of the LLM.
Yeah.
Because you're not affecting the weights of the LLM and fine-tuning them away. So, I'm quite bullish on this approach going a long way.
Yeah, that's amazing. Well, it was flawless. So my congratulations.
Yeah, thank you.
Amazing.
So like diarization is kind of solved. It's not, it's not solved, but it does work.
Yeah. What do you think about neurosymbolic?
It's a term that I think used to make me a little uncomfortable. Very much a sort of pure connectionist by heart. But I think I've come to appreciate that there's some applications where this is the correct way to do things. So if you have, a particular application you want to solve the game of Go, you want to search through a particular search space, English sentences, actually combining a neural approach with a more symbolic approach is very, very helpful. And, the way that I think about, say, the decode that happens in ASR, WFST decode.
What does that mean?
It's a weighted finite state transducer. So these are these kind of data structures over which you can operate and you can do a search through, and they define the costs of certain paths. Yeah, we can do a search over these things, and they can constrain what is possible in English for you. This is great. Like this helps us define an API as a company. So from like a product point of view, this is brilliant. If you're doing multi-college research, this is also a very useful operation if you have a particular setup. And so, I'm not gonna denigrate these approaches because they're obviously useful when you're very, very applied. Then I think you get to the question of like reasoning and, the AGI question and whether they're going to be required there. And I think this may be where we slightly diverge on how we think about things, because I think I'd continue to be quite connectionist there. I think we want open-ended reasoning. We want flexible kind of building of these programs and planning abilities that are very situational. But I believe that's going to emerge from certain prediction tasks. I believe that if we're modeling at the right levels of representation, that we can do planning implicitly. And so the more primitive operations can approximate these discrete programs that we write more explicitly for things like, Monte Carlo research, for example.
I kind of agree. I think that the statistical approach will get you to a place where the correct program is in the space. But don't you still need to have, because the beauty of having like an actual evaluation function is you can actually run the program and you can verify it and you can select the provably correct path. So we could get to a point where we like probabilistically select the program that we think works, but we don't know that it works.
Well, I'd argue humans are in a position where we have a state in our brains and we don't know that certain actions are going to provably get us the results that we want, but we have a certain level of experience in our environments that refine those representations, those predictions, those actions, such that we achieve the goals that we want. It might be a quicker way there. You might be able to put more guarantees around things, but I'm not sure it's completely necessary. And I think, like, going back to what I've been saying before around, representations being, I think, one of the key lenses through which to see things. I think if we have the right representations that are clocked at the right rate, they can almost have your plan encoded, in a very dense kind of vector almost, that can then just be unrolled.
Yeah, I agree. I mean, there was that great work by Benjo, GFlow Nets, that did something very, very similar. And also, I should say that even when we do system 2 reasoning, we're not actually verifying completely. So on an IQ test or on an ARC challenge test, we can verify the program against the test instances. And we only have 3 or 4. And actually, there are an infinite number of possible programs that could generalize. And we anthropomorphically select the one that is the least complexity, the most anthropomorphically aligned or whatever. So it's not a perfect process. But it feels different. It feels like there's some kind of meta process of evaluation, and that's our system too.
Yeah, but there's lots there that we can't get our hands on, like aesthetics.
Yeah.
That we'll never get our hands on almost. And if we have that happening inside a system, we'll also not really get our hands on it, I don't think. And that should be okay.
But I also love this deliberative program that humans have. So we ponder. So we just kind of iterate and we just sort of and then at some point we halt.
Yeah.
And neural networks are always that instant intuition. Yeah. They're always like, this is the answer. Yeah. And I can imagine some kind of, it's not necessarily neurosymbolic, maybe it is, but some iterative approach of reflection, bringing in more contextual information and then somehow arriving at the correct answer.
Yeah. I mean, this is exactly kind of how I see the conversational AI of the future working is you take in a frame from your environment at every single step. And that should cascade through the system and update various things. And maybe you decide not to output any speech. You just get zeros on the output. But then you go again. And that whole time you've had time to ponder. Maybe your high-level representations have clocked forward. Maybe they haven't. Maybe you haven't updated your high-level beliefs. There's an opportunity to. So actually, I think we can construct these systems in such a way that that's kind of possible.
How would that work? Because I wanted to talk to you in general about the architecture of conversational AI. So at the moment, I talk to Speechmatics, and let's say I'm doing async. So I have a stream coming up of audio data, and it's like PCM 16, little endian. And then I have a stream coming down of JSON packets, which tell me like the time indexes and the words and so on. And this is just a constant stream. And it would be great if there was some kind of meta thinking process that could kind of like ponder and update. Because right now, if I want to build a conversational interface, I guess I have to do a lot of the work. I have to build the UI and I have to kind of like think about the meta model and the application structure. Would you ever design a system where more of that meta model kind of happens on your end?
Yeah, so we're thinking about this. I would like an end-to-end kind of approach that can do that. I think for the time being, cascaded approaches are going to go a long way because you don't have to, and by that I mean you have an ASR system, you hook it up to an LLM, you have a speech synthesis system, you compose them, you try and reduce latency between them. And this works fairly well, actually, by the way. So you can get latency down to like 1.2 seconds. And then this is what we do is like we'll pad up to the 1.2 seconds to just give a very consistent user experience. And that's fine. But there's not much kind of meta kind of cognition going on in the LLM in this kind of scenario. So to get to that, you have to kind of flip paradigms to a much more end-to-end approach. And there's some interesting research questions around how we get that system doing what we want. I think a lot of the energy at the moment is trying to set up multitask problems such that you can do well on processing the audio, being able to exploit some of the paralinguistic stuff that happens in the speech and make use of it in some way that you wouldn't be able to make use of if it was just converted to text, and then sort of mirroring that on the output and producing sort of speech with appropriate kind of emphasis. I think that will take us so far, but there's still this. It still won't have this kind of like meta reasoning that you were just talking about. So there's a bit of a paradigm change that's needed there, and I have like a very, very strong belief that until we can arrive at subword like level representations directly unsupervised from audio, that we will struggle to do that.
I just had another thought as well, that at the moment there's an async service, there's like basically a streaming service from Speechmatics and there's a batch service. Yeah. And the batch service is much better because it has more context, or their streaming is still really, really good. Yeah. And one thing I've been thinking about building conversational applications is having a kind of hybrid where, because we want streaming low latency, we have the raw information from your stream, but then we do some kind of like retrospective multi-scale post-processing with an LLM. So after an utterance is completed, maybe a couple of utterances ago, we have another meta process which is running it through the LLM. But the thing is, the LLM might be a multimodal thing. So it's actually looking at a screenshot of the UI. I'm sending it the event log of all of the buttons people are pressing, and maybe some external information, contextual information, and it's using all of that to kind of like improve the transcription retrospectively.
Yeah, this sounds good. And people have done things like they'll take a snapshot of your mouth, and they'll use that to improve the accuracy of the ASR.
Yeah,
how your lips are moving. And so, like, any of this additional metadata that can come in to improve the transcript, there's absolutely nothing stopping anybody going and doing that, and it's probably a good idea, if there's a particular application in mind.
Yeah, I've thought about that a lot, actually. In the lip reading literature, I think the accuracy is still quite low. It's about like 56% or something, but it's really cool having this multimodal approach. So I can see your lips, I've got your audio stream, and also you can use face recognition for better diarization. So I can enroll you, so Will, I talk with Will, and I can tell when Will's talking, and when Will's talking, I use that to refine the diarization boundaries and so on. And it feels like the more modalities of data we have, the more we can kind of smooth off the edges.
Oh, definitely. I mean, I'm a big proponent of, having data streams come in that are the same as what we have as humans, a really rich source of audio and vision. And it'd be great if that was there by default for a lot of these applications, plus more, probably.
Yeah, amazing. So like in a future version of Speechmatics, I'll be able to just give you like different multimodal streams.
That would be great. I mean, if we can profitably make use of them, absolutely.
Yeah, even stuff like the accelerometer on AR glasses. I mean, so it's almost like spatial information, visual information, audio information, and maybe even social information. So maybe in the future we'll be kind of connected spatially to different people in the vicinity, and all of this could just kind of go up.
Yeah, definitely. I think like some of these modalities will just drop in there very, very easily. I mean, I'm envisaging an unsupervised training process that can make sense of these different modalities and their interactions between them. I think a lot of these additional ones we can just bung them in, and we'll be able to make use of them.
What's your take on the whole LLM space at the moment?
There's obviously a lot of activity, a lot of really big models being trained, a lot of interesting economic activity, I think, around it. I suppose the angle that I'm most interested in is how these models leading us towards future, more generally capable intelligent systems. And I do have some question marks around the amount of energy and almost fanaticism that's surrounding the scaling hypothesis, that we just need to continue scaling this current paradigm: next token prediction, transformers, internet text. I do think that these systems will start to slow down in terms of the rapid progress that we've seen currently. And maybe GPT-5 being pushed back is a bit of an early sign for that. I'm not sure. We'll have to see when that model drops. But yeah, these models are clearly very, very good for certain activities. Text processing, coding, as being an alternative to Google in some cases, very, very powerful. But it's clear to me that there's a level of generalization that maybe isn't happening in them that we're seeking ultimately and that we need to build bigger and better systems. Yeah, I put a question mark on the text internet data piece in particular. I think there's a limited amount of statistical significance that you can get from adding more text tokens versus what we've got today. And maybe it has to be an exponential increase in data. And I think the scaling laws will bear that out. There's a bit of an open question on how far synthetic data can take us. I think it will iron out a lot of, particular use cases where you want to, format your data with a certain table of contents, or, a mathematical kind of application where we want to prove theorems in a certain way. Maybe synthetic data will take us a bit further, but it doesn't seem to me that training on the next token on internet scale data, text tokens, is going to unlock the kind of reasoning capabilities that that lots of people want to see emerge. But if they're honest, they haven't really been happening. There's lots of low-level reasoning that certainly is happening, but this aspect of creativity, inventing new things, it just doesn't seem to be happening. And I don't know, I feel like there's also a community kind of polarization over this issue. One half is saying, well, of course, these things, aren't doing that. And the other half is saying, well, there is evidence of it, and let's just scale it further. I think there's maybe a bit of truth on both sides there, but I don't know. What do you think?
Well, I agree. I think the problem is that in a way, both communities are right. So the models are clearly just system 1 systems. They're not system 2 systems. And what's surprising everyone, myself included, is how far you can get with system 1. So just this interpolative reasoning does actually give you probably gives you the right answer for the wrong reasons, but it doesn't matter. It gives you the right answer a lot of the time. And as we memorize more of the long tail, it increases to, its performance increases still further. And then there's the thing, well, if we want it to get system 2 reasoning, this kind of creative reasoning that happens in the moment, how often do we actually need to do that creative reasoning? I think that's the question. I think they're still arguing that we can push system 1 a little bit further and it will just improve.
Well, I suspect you can compile things down from system 2 to system 1 with sufficient data and the right setup. But that almost assumes that you've got the system 2 piece. And I think it will become exponentially more difficult to learn these behaviors.
It's weird. Ryan Greenblatt said something interesting the other day. He said that you can always get a dumb system to approximate a smart system if you just throw lots of data at it. And that's kind of what these things are now. I mean, these LLMs are idea generators. And quite often the right answer is in the possible set of trajectories. So you just need to keep asking it. And then you can hack together a solution with tool use and evaluation and selection and so on. And you can often get the right answer out of it. So because these systems are so flexible and hackable, it's possible to just make them work a lot of the time. And in a way, that's something that's quite tragic for me because no one's looking at any other forms of AI now.
There is a certain level of tragedy around it. But I do think we need to push the current paradigm to its limits. I guess you get into the finer questions of how much do you want to then spend on a big training run. But I think we need to just realize almost by construction that once we scale these to a certain limit that we're not able to extract maybe more out of them.
Yeah, and I think we're going to see that soon. I mean, when I spoke with Aidan Gomez, he actually said to me that more than half of their data at this point is synthetic data. Mm-hmm. And I don't know exactly what he meant by that because it's not easy to generate synthetic data for language. I mean, maybe they've got a whole bunch of programs that do stuff like that, but it's already like a massive amount of synthetic data. And I'm guessing that we'll see some kind of saturation with language models. When I speak with people like Sarah Hooker, she's already saying clearly that, in multilingual models, they're not really generalizing very well between the languages. It is just a case of learning these distributions. But because they do work so well and there's this mechanical Turk thing going on at OpenAI, there's the perception that they're better than they are perhaps. But are you worried about this? So when you see these multimodal GPT-4o type models, lots of people might naively think, we don't need Speechmatics anymore. I mean, what would you say to that?
I'd say run the word error rates, to be honest. Do the eval.
Yeah.
Because I think if we want to have a platform, like a voice platform, with which to interact with machines, we want to have some level of guarantees around accuracy and whether it's going to get my words correct. If all my frames of my sort of speech are being bunged into a giant attention mechanism, and some of them are being dropped or some of them are being misrecognized, I'm not sure how comfortable I am with that. Certainly, I can see that the speech problem isn't solved, and there's a lot more to do.
Can you see a future where I was playing with Moshi the other day, which is like this new, bidirectional low latency model. And it's the first time I've seen a bidirectional model for, that does ASR and language modeling and so on. Super low latency. It wasn't very good. It hallucinated and did lots of crazy things actually. But, as a kind of, template for conversational interface, it was quite cool. But, could you imagine a future where OpenAI just completely changed the architecture? They had like a bidirectional model, that had like real-time input and output and so on. Like at that point, would you be worried?
I think I'm only worried when I see the numbers, to be honest. I need to see the hard facts. And I'm not sure those changes would necessarily get them to a system that does, for example, better live captioning. Doing ASR in real time. This is one of our differentiators, like accuracy, real time, low latency. Seen very good numbers there, and I'd want to see a big shift there before I really got worried, to be honest.
Yeah,
I think these kind of like full duplex conversational assistants are very, very interesting. I do think conversational systems should be modeling their own voice, for example. So if they're speaking out and they can't hear themselves talking in the room because it's too quiet, they should automatically modulate their voice up. This is the type of thing that we should see happening in systems. And we just don't. I mean, no one thinks about this. So yeah, being able to sort of model your own voice and have this kind of bidirectional interruption possibility is very interesting. But there needs to be a heck of a lot more smarts sitting behind it than currently. I think in the particular demo that you mentioned, there were lots of times where you couldn't really finish your sentence because it was sort of trying to interrupt you and talk over you. And so that experience is very unnatural. And then there's a problem of having these systems kind of maintain their LLM knowledge and how well it does that. So I think there are challenges there. But these are challenges that we're interested in working on. So
are you interested in augmenting your models with LLMs in any way?
Yeah. So we know that LLMs have very good sort of long-term consistency. So if you have a very long transcript, the subject matter can be ingested by the LLM. It can understand what topic you're talking about. It can understand the finer details. It can go fix up, silly mistakes. So this is really good. And there's other workflows where LLMs can get involved on transcripts, which make a lot of sense. We already support some of these, summarization, chapters. We're looking at ways to integrate LLMs more into our core pipeline because they clearly have a good level of world knowledge that it'd be very useful for SR to have.
And would you train your own LLMs or would you use another provider?
We would probably use open source models for this because there's a certain threshold beyond which they're useful for this kind of world knowledge. And so they need to be large models, and therefore we're not going to be training these ourselves from scratch. We may want to fine tune them.
When you're developing these models, there must be a massive trade-off between, how much it costs to build the model and its performance. How do you think about that?
In our case, we're training models that are, let's say, under 10 billion parameters. So the train costs are not too prohibitive, particularly given we have some costs in terms of an internal cluster. That side of things is fine, but the economics of inference is interesting. So what kind of performance do we want to offer? What's the word error rate that you can get per dollar? These types of questions, density, latency, we'll look at all of these. And so one of the things that we've decided to do is have multiple operating points that sort of sit at different points on this kind of curve. So we'll have a smaller model that's higher throughput, that's more efficient to run, slightly cheaper. And then we've got our premium enhanced model where we want to just optimize for accuracy almost at any cost. We want to just make sure that is as accurate as possible. And so, we think there are a couple of interesting points to sit on that curve. And that's very much guided by our product team.
What do you say to people who argue that speech tech is just becoming commoditized? Like with the ImageNet thing, It was kind of seen as a solved problem at some point. Do you think we're anywhere near that with ASR?
I think for batch English, it's getting closer. I definitely know the ways in which it fails because I'm obviously a big-time user of this tech and I'm testing it all the time. So I know that for conversational AI, we're still not quite there. But definitely more than anything, batch ASR has been just big advances in the field, which has been great to see. I think non-English languages are lagging behind by 3 or 4 years, roughly speaking. And then maybe real time is got a 3-year lag on it, or 2-year or something like that. So people are struggling to maintain this kind of accuracy at real time, which obviously becomes relevant when we're starting to build conversational assistants, which we're starting to get into. So
I'm interested in your articulation of where, because you said where the failure points are. So for example, when I was building X-Ray, we noticed that it was quite bad in noisy environments. But we also noticed that, Speechmatics does an incredible job of lifting low speech. So we didn't need to do any audio processing. We're not normalizing the audio. We're not pre-filtering. We did suspect that if we did something like source separation, because the cocktail party problem is a big one where you have multiple people. Yep. And what we noticed is that some of the models seem to implicitly do something which is akin to active source separation. So for example, when I start speaking, it seems to lock onto my voice and ignore the voices in the background. And this is presumably something that you haven't intentionally done.
Yeah, this is an artifact of the training data, almost certainly. So yeah, it will continue with the dominant speaker. Yeah, but this ability to do source separation and deal with crosstalk is a big area where the current generation systems are just like architecturally not there. There's obviously some papers that deal with this in particular ways. It's a big kind of failure mode. As humans, we can decide I want to attend to this particular voice and do a really good job of recognizing it and continuing the conversation. These models are very, very brittle on that right now.
It's actually interesting because there's a whole cottage industry of startups, and their sole purpose is to pre-process audio data pre-ASR. And I'm assuming over time, the benefit of that is getting smaller and smaller because the ASR providers will just kind of do it implicitly.
I was poo-pooing supervised learning earlier, but here's where it kind of comes to save you a little bit. If you don't pre-process your audio and you have really big distribution, you're going to cover all of that.
Yeah, because I'm thinking as well, like a future scenario might be with active inference. Customers might be wearing, let's say, AR headsets, and those headsets might do adaptive beamforming, and they might do a whole bunch of stuff, and then that could be almost an active signal which is modulated by the ASR algorithm. So we're getting into much more kind of situated physical intelligence.
Oh, that'd be very exciting.
Beamforming is another big one. There's like TDOA, and we looked at that, and also source separation.
Yeah, that's really cool. Yeah, I'd be interested to know how far you got with that, actually.
Yeah, not very far. But the phones do it. So, for example, on Android, it's all built into the audio APIs, and they actually have a feature called microphone zoom. So that means that when you set the zoom to 2, it's already on your camera, by the way. So on your camera, when you zoom into someone over there, it's doing beamform on the audio, and it will actually ignore all of the people in your vicinity and plug into that person, and you can do that programmatically through the API. The problem is it's useless from an audio app point of view because you're not going to be like pointing your phone in a certain direction.
Zooming in, yeah.
But the thing is, people have their phones. They don't have powerful directional microphones. So like a lot of like deaf folks, for example, they want audio transcription. They probably have to buy specialist directional microphones, and then it's not very practical. But hopefully these AR glasses will help them with that.
Yeah, that's cool.
How often do you release your models, and how stable are they?
We do weekly releases. They may or may not include a major update to our most significant models. Those models will probably be updated on a sort of cadence of 3 months, maybe slightly longer, depending on the projects that are backing it, I suppose. As for stability, we have a lot of internal testing. We have soak tests in real time. We have unit tests, functional tests, lots of performance tests. That's a big focus right now. So we can make sure that we're operating at the accuracy that we claim at low latency, and we have lots of wood error testing. So by the time we've got a release candidate that's been sort of approved and ready to go, it will have had a real battery of tests. And something that we've been building out over the years on the machine learning side is getting a really wide set of test sets to make sure that we're not regressing on our sort of core metrics, which in an ASR is word error rate.
Do you have like a rollback strategy? I mean, what happens if something goes wrong?
Oh yeah, so I forgot to mention, one of the things we do is we'll run in a mirrored environment first. So we'll deploy our new models directly to an environment which takes mirrored live traffic for a period of time. And there's lots of weird and wonderful ways in which people can send audio files in, which just bring unexpected results. There's lots of configs that are interesting. So that has been a surprisingly effective tool for us. Is having mirroring, and yeah, I would love us to bring that testing closer to the build, and not necessarily have to have it so we can release quicker. But it just catches so much that it's been really powerful for us. Yeah, as for rollbacks, yeah, we can roll back to our previous version. So we've got quite a lot of sort of DevOps maturity on that side. So we're not afraid to go and do a release, and we can canary it as well with certain parameters should we need to.
Yeah, having these models, they're huge, right? And if you wanted to keep a couple of older versions up and running, because let's say one customer or a few customers had a big problem, and you might want just them to go back to the old version, but everyone else uses the new version, would you be able to do that?
Yes, we can, and we do. So sometimes there are just circumstances where, we'll want to just be a bit more careful with a certain customer. Maybe because they're waiting for a certain feature that they're about to release, and we'll give them early access and then give them their own sort of upgrade path. So yeah, it's really good having flexibility there.
Another interesting thing is that some of your customers choose to fine-tune the models on their own data. Is that correct?
That's not correct.
That's not correct. So I'll edit that out.
Well, no, it's a really interesting discussion. So
okay.
It's been an ongoing strategic discussion whether we should allow customers to bring in their own data, fine-tune the model, get a ostensibly better final result. And we've gone the route of building global models where we'll try and get as much data as we can that's as representative as possible, and make it so that fine-tuned model is just as good as our original global model. And on the whole, that strategy has worked. I guess in machine learning, if you do have like a prescribed domain, you can fine-tune and get a better model. But looking at the maturity of ASR systems, it's not a massive gain, and it's not, and the complexity that would come with that is not a brilliant trade-off in my book. We've put all our energy into getting that 5% for our customers by, instead of building that whole system where you can go train it and fine-tune it yourself, putting it into general gains and just pushing accuracy really hard across the board. And I think that's worked well for us.
Yeah, it must massively increase the architectural complexity, especially if the models are big, because you need to load them into memory, and then they might not be used all the time. Because if you have like one big shared model, you can have elastic autoscale and pooling, and you've got other people using the same model. Now all of a sudden you've got this weird esoteric model that one customer uses every Friday afternoon, and you don't know whether to load it into memory, and you've presumably got to replicate it to different data centers in the world and so on. It makes it really difficult.
Yeah, it'd be expensive to host. I think it makes more sense on-prem, for sure. So if customers going to run it themselves and they're going to run it with just their traffic, you can get good utilization there for them, which is nice. But yeah, if we're running it in our SaaS alongside all our other models, that becomes painful at that point.
What does your sort of high availability and globally distributed setup look like? So I guess you've got servers in different countries, and in your release schedule, they'll automatically be kind of distributed to different countries. And ASR, especially the the streaming version, it's very latency sensitive. So people want to use their local servers.
Yeah, that's right. Yeah, so we have one in EU, we have a couple in the US. I think we've got one in Australia as well, and we can stand things up on demand for certain customers as well if we need to. So yeah, we're sensitive to that, and as our customers. So we will deploy to a number of different environments.
Interesting. Tell me about latency.
Yeah, so latency is a really interesting topic in ASR because nobody sees low latency numbers when they look at word error rates. There's only the sort of full batch, full fat system that if you're running captioning, you're never actually going to use. Something we've been pushing internally quite hard recently is looking at latency accuracy curves. And, we want to be sort of Pareto optimal there. We want to sort of dominate the competition. And so, so we've been looking at our accuracy at various different latency points and doing some things to really push that curve down and to the left. Yeah, that's been a very fruitful exercise. And it's something that I think the industry and academia probably need to, do a little bit better at reporting is, okay, what is the accuracy of the system when we're running it in real time at a reasonable latency? And very, very few people do actually quote on that.
Yeah, you said something interesting as well, because you're talking about latency curves. So a lot of people might not appreciate this, that you can actually set the latency. So you can set it to be, let's say, 300 milliseconds or 500 milliseconds. And the longer the latency is, presumably, like the more information you have. So how does that work? I mean, on Speechmatics at the moment, is it fixed, or can the customer set it?
Yeah, customer can set it.
Oh, right.
I think at the moment you can go down to, 0.7, 0.5 seconds and still get reasonable performance before it all falls off a cliff. And then you recover your sort of full batch performance by moving out to like 4, 5, 6 seconds, something like this. And there's a graceful sort of like transition between those two sort of modes of operation. But yeah, the idea is that if you set a lower latency sort of target, that the system has to sort of output its current best guess. It's all sort of probabilistic. And so, you do have a current best guess. But if you give more time, you can bring in things like a language model that can update all your hypotheses, give you hopefully a more refined score on what you've been saying. And so you do typically feel the difference of waiting a little bit longer. And one of the things I think is interesting to think about is, well, as a human being, how would I transcribe this optimally? What would my latency be? If I could immediately just choose a word and write it down, what would my latency be? And actually, sometimes it pays to just wait a little bit to try and disentangle what somebody has said. And that's no bad thing. And I think the same thing goes for the ASR system. We don't really want systems at 200 millisecond latency. That's just not useful. You're going to get mistakes if you set it that low, even with like a perfect system.
You said something interesting about having like a language model do some post-processing. So how does this work? I mean, are your models just like, you have the waveform domain and you might do some feature extraction and you have this model and eventually you have words coming out the end, and then you're alluding to, a secondary model almost improving the results of the first one?
The big picture is that we have a lot of text, and everyone who's building LLMs out there is going to obviously be aware of this. But there's information there that you want to exploit if you're building a speech system, and actually not to do so is just to put yourself at a disadvantage. So we need some way for this kind of knowledge of how words follow each other to be integrated into the system. And the different ways of doing that sort of distinguish the different ASR systems. So people have tried lots of different ways of getting that knowledge in there. Yeah, one of the ways that we do it is we build a lattice that has like a directed acyclic graph that has all of your hypotheses contained within there, and we march over it with a language model arc by arc, and we will update the scores. This is like the full fat version of ASR. It adds a bit more to your latency to do it that way, but it means that we can, you can inspect these, you can do lots of good things with lattices, actually, lots of interesting FSD operations on them. But yeah, it means that you can bring a big language model in there, or an external language model as it gets called, and update those scores. And that language model can be as big as you like, as long there's no sort of restriction. And so we really should be seeing the power of these LLMs coming to the ASR world.
Yeah, can you spell out to the audience what a lattice is? So, like a grid is a type of lattice. And this might be quite strange for the audience because, they think of language models as just almost being over a flat sequence. Yeah. But you can actually have some structure in that.
So you have some nodes and arcs, and you can imagine transitioning across an arc if you sort of consume a particular word. What ASR kind of does is it considers the infinite number of paths that could exist if you progress from word to word. So it's time-based. So at any given moment in time, maybe I've spoken a few different words and you're not sure. In fact, it could be an infinite set of words, but the recognizer will then pare it down and hopefully just output the ones that are probable. And so you can follow your way through this lattice to an end state. So you have a start and an end state. And all the different paths through that should be fairly legitimate sentences. So it's not just a fixed grid. Maybe things converge at one node halfway through because that is it's dead certain that that's what's been said, and then it goes on again.
Does this happen in a stateless way? So we're doing transcription, we have this lattice, we do some kind of optimal traversal, we pick the next word based on some algorithm, and then we have another load of audio data come in, and we go through the whole process. We do the feature extraction, we do some predictions, we do the lattice, we do the traversal again. So it's almost like an autoregressive language model, and every single step is stateless. So it's not in any way affected by the step before, other than the result of the step before.
Yeah, I mean, I guess it depends how you wire things up. So you could technically make it stateless. Your acoustic model is going to have some kind of horizon, some context length. So is your language model. It could be attending to something you've said like half an hour ago. That's technically possible. And same for the decode as well. So the way that I think about ASR is kind of you have these three components that have to come together in some way, which is like the acoustic model, language model, and a decode, which is like a search process, which will produce this lattice. And they each can have their own state. So they can be incrementally sort of updated.
Oh, that's interesting. Yes. So all of them are parameterized, and those parameters kind of drift over time. But the interesting thing is that you are actually doing, I guess, some kind of a beam search or some kind of a future search. So you're kind of predicting what could the future look like many steps ahead, and then you choose one, and then the next step you're kind of starting again. And now I'm looking at all of these future trajectories.
Yeah, exactly. Yeah.
Yeah, that's pretty fascinating. And then it just works.
And then it just works.
Just like magic.
Yeah. It definitely didn't feel like magic, 10 years ago. It was, the word errors were very, very high, like 35%, and now we're down like 5% or something. It's just sort of rough sort of picture. So it does feel more like magic now, for sure.
And these are probabilistic systems. I mean, I was talking to Murray Shanahan, and he was talking about this thing called Loom, which is where you can look at all of the conversation trajectories. So you could ask an LLM 20 questions, and you can say, think of a thing, and then you can kind of go through more of the questions. And you think that the language model has internal consistency, and the thing that it actually thought earlier on will be what it said later on. But any of the subsequent steps can actually make it diverge and say something completely different. But we look at it as if it had some self-consistency, which is kind of weird.
Yeah. And you have that exact same branching kind of process happening in the search for in ASR. You just prune away the stuff that wasn't likely under your language model and wasn't likely under your acoustic model.
So these things are just probabilistic models?
Yeah.
They don't reason?
Well, there's a big discussion. I don't think they do.
Go on.
I think this is the thing with supervised learning. We are just learning a mapping. And maybe there's some very low-level forms of reasoning that you could say exist there. But this is very much a dumb mapping. And I think this can be seen by the levels of generalization that happen. So one of the things that we've been talking about previously is out-of-distribution generalization, how it's not really happening in ASR in the way that people believe it is. I think that's a bit of a clue that there's not the type of reasoning that we'd recognize happening in these systems at all. When they generalize in ways that we generalize, I think we can maybe revisit that question. But when and until they do, I'm very, very skeptical that there's much reasoning happening at all.
So the question is, why do they generalize? So I mean, I was speaking with Sarah Hooker from Cohere last week, and she's really grumpy about the EU AI Act and the executive order in the States, because they've just set a threshold of the number of flops above which models are dangerous and below which they are apparently not dangerous. And there's this idea that there's some commensurate relationship between risk and generalization and the number of flops, the amount of compute power that goes in. And she argues that the reason for that is, well, yes, of course, there's a commensurate relationship between compute and capabilities because the models are just memorizing more of the long tail. And people look at that and they confuse it with generalization ability, or OOD. But what's your take?
On the AI safety question and how we should be regulating it, my view is that we should be a little bit overcautious to begin with in general. So I wouldn't be completely poo-pooing, these new moves, but it does feel quite over the top in general. But we're having some of these conversations because we don't really understand the types of generalization we're shooting for and when it's emerging and to what extent and how do you measure that. I think tying it to flops is questionable. It's a bit like saying in ASR, I've got a great turnaround time. I can turn around things in 0.001 real-time factor RTF. It's like, well, great. Did you actually return me the correct words? Were they actually in there? And it's the same thing with flops. Like, well, great, you can run a huge amount of matrix multiplication, but what's actually happening behind that? And we're a very long way from consensus on that. So it like I say, when there's a bit of uncertainty, I'm actually okay with us being a little bit over the top with regulation, but it has to be pared back quickly, and that's as we learn more. And I don't think that's going to happen. So that's where my grumble would be.
Yeah, because she was saying, she trains multilingual models. So she has to do more compute because she's actually learning completely different distributions of data in different languages. And it is a simple case of I've just got more stuff to do. I've got more stuff to learn. And the problem seems to be whether or not they actually do some abstract generalization between those distributions. What's your take? Because obviously it's interesting, right? Because you actually work at Speechmatics. You're building these systems. You've seen behind the curtain. You know how they really work. Yep. Are they doing magic generalization, or are they just like memorizing more of the distributions?
There's some level of generalization happening. I'm one of the biggest testers of our system, so I can see, some of that impressive generalization that does happen. We get the right words on distributions that we've never trained on, which is good. But I think people are worried about a level of generalization that goes way beyond that, which I haven't seen. I think one of the simple ways to evaluate this stuff is to do it qualitatively. I think you're a big proponent of this as well. Is I'm going to take the system and I'm just going to interact with it very simply, and you can get a good feel for the level of generalization that exists. And I'm not sure we're on a trajectory into dangerous territory there. And so, yeah, and also just having it as a kind of straight flops calculation, like Sarah, I guess, was saying, just makes no sense.
Yeah, I mean, talking with Murray Shanahan moved me a bit on this because, you can make technical arguments about, the limitations of reasoning. They're clearly doing a colloquial interpolative reasoning, but that actually works really well. And when the model gives you the correct answer, I don't think it's necessarily correct to say it's not reasoning. It's arrived at the correct answer. And I really liked your point about the qualitative evaluation of models, because, we've got many ways of evaluating language models, for example, like LLM Cicerina and so on and so forth. But it's the same thing with Speechmatics, right? So I built a speech transcription company, which was like, using various different APIs. And in my opinion, many of the companies basically lie about their benchmarks. And I would just use the thing. And the thing is as well, the benchmarks, they generalize over everything, like real world usage. I'm actually using the thing in my noisy cafe or in my bedroom or talking over the phone with someone. And the results are plain to see. It either works or it doesn't. And it's usually obvious which is best. Even when I use language models, I use like, Sonnet 3.5, love it. GPT-4o. You can just use these things and, maybe like I'm deluding myself a little bit, but I can feel it. I can feel the difference. Can you feel the difference?
Can you feel the AGI? Yeah, I think I can. I think you can roughly tell how a system is doing just by using it. We are very good evaluators of these systems, and that's underappreciated. I definitely think benchmarks have that place. It's almost like they're sort of necessary but not sufficient. Like, we want to be passing our benchmarks that we care about and that we've done well on previously, particularly at Speechmatics. But it doesn't tell you everything. We've seen this actually when we made a sort of a change to use self-supervised models in our system. And we did the training, we did the evaluation, really happy with the results. And then it was only like a few months later that we saw someone put some children's voice through, and it started to recognize it correctly. We didn't have it in our test sets at the time. And so it was generalizing in surprising ways that was quite exciting. And so, benchmarks are definitely not going to catch everything.
Yeah, and there's this kind of Goodhart's law thing as well, which is when a target becomes a measure, it ceases to be a good measure. And the great thing about subjectivity and evaluation is that everyone has access to a source of randomness and novelty, which means you're actually getting very useful signal there. But then the good thing about benchmarks is standardization, which is that you have this one golden mark that that rules them all. So it's quite difficult to interpret the subjective reports of many people.
Yeah, and I think benchmarks drive progress really well when you're in a certain regime. When you're in the sort of like ImageNet and LibreSpeech kind of space where they've been like flogged to death in academia, there's just less signal. So it's like, you go through its early phase of lots of signal, and then less signal. You have to go replace it with the next thing. And it's really important to recognize when that's happening and move on. I think as a speech community, I don't think we've been very good at moving on from certain test sets, for example. In fact, things are no longer test sets as soon as you've used them for a certain period of time. I mean, this is fundamental to appreciate that that people are ultimately going to be optimizing against that test set result by the sort of meta decisions that they make, the architectural changes that they make, and so on.
Yeah, I know. I think this is something that people don't realize is the amount of information that leaks from the test set, sometimes indirectly. Yep. And Francois Chalet knows this. So this is the reason why he has fastidiously guarded the private, ARC test set. And even then, though, it's still kind of leaking, because people are starting to make inferences about what's in that set based on generalization patterns in the public set. And eventually, one day, there'll be a spark because someone will figure out a thing that works on the private set. And then it's gone because test sets rot over time.
Yeah.
So what do you do? Do you guys have like a private test set, or
we have a whole bunch of private test sets, that we trust, and we'll run them against our stuff. We'll run them against competitor stuff. So we really know what's going on in the market and how well we're doing internally as well. And it's important to keep adding to that because you got to be real with yourself. That you're not, you haven't suffered this kind of leakage problem. Even if it's very indirect.
How do you mitigate that? Because I guess even in your internal testing, how do you not inadvertently kind of overfit on your private sets?
Well, we have to have checks for leakage and that there's no overlap with our training and test data. Obviously, that's really important. But beyond that, we want to look at the distributions that we're training on, making sure that we're not overfitting to one kind of distribution. So yeah, that kind of goes into planning, but it kind of goes along with our overall approach that we want to continue to widen that distribution. Because as long as you're sitting with the same distribution for a long time, you are susceptible, I believe.
So Will, are you going to give us a demo?
Yeah, well, I've got a few demos lined up. One of them's on the laptop here. Should just be transcribing our voice and doing some live captioning, which is one of the big use cases that we have at Speechmatics.
Amazing. I didn't tell you the story, but when we last interviewed Noam Chomsky, we used Speechmatics in X-Ray, and we were actually sharing our screen with the transcription. And it was only because of that transcription he was able to understand us, because he's profoundly deaf.
Oh, wow.
And we're going to release that video soon. But it was thanks to Speechmatics.
Wow, that's really cool to hear.
Yeah,
really
so
cool.
I guess we've built a similar app to this. But so let's look at the accuracy then. What's it doing? The latency is incredibly good.
Yeah, this isn't released yet. Maybe it'll be released by the time podcast goes out. But the latency, I think, here is at 0.8 seconds max delay.
0.8.
Yeah, I think so. Yeah. Which means some of it will be coming back faster than that. We've also got the partials turned on, so you can see how fast the engine is actually operating behind the scenes.
Yeah.
Some of our customers won't want to use that at all, actually, if they're doing live captioning. But it's useful just to get a feel for how the engine works. Yeah,
I love having the partials on because from a UX perspective, it makes it feel much more responsive.
Yeah, I'm quite used to reading them, so I quite like them. But I know there are some people who it just kind of messes with their brain a little bit. So.
Oh yeah, well we render them on X-Ray. I'm a big fan.
We want to have a really consistent API. So this is one of the issues actually with Whisper is we iterated through numbers from like 1 to 10,000. We synthesized each number. We pushed it through Whisper, and it just hallucinates on a whole bunch of numbers. So there's like some numbers that you cannot get correct with Whisper.
Really?
Yeah. And maybe it's been all fixed since we ran this on I think V2. But yeah, so that's like a good example of the hallucination problem. But what we'll do is we'll recognize the spoken form and then apply like a deterministic inverse text normalization function on top of the words so that you can get things like 3.141 rendered correctly.
Wow, that's interesting. Do you think they now do, synthetic data for audio? Because they presumably didn't on Whisper 1.
Yeah, I think you would probably need synthetic data to cover some of these edge cases.
Yeah, that's so fascinating because Professor Christopher Summerfield called it the Swiss cheese problem, which is that sometimes you're in a hole in the Swiss cheese, which is to say you're in part of the distribution where there's no data, and then all of a sudden the models just don't work.
Yeah. I mean, this is where end-to-end models do actually have a disadvantage, is that you have to make sure you're covering that distribution with the audio itself.
Yeah.
Which can be quite costly, and you just have to go collect that data if you need it, or synthesize it.
Very cool. So this new model, will it work with your existing API so people can just switch over to the new model?
Yeah. This should just be an immediate change that appears on our cloud.
Wow. Very cool. I want to use it. Can you give us sneaky squirrels access to it?
Yeah, almost certainly. Yeah.
Yeah, amazing. Yeah, we almost need some esoteric words like supercalifragilisticexpialidocious.
I think it's got it, but it's split it into 2 words. But I'll take that.
Yeah, self-attention transformer theory, bidirectional transformers, neurosymbolic architectures. It's not bad. I mean, I must say we are using incredible microphones here.
That's going to help.
I think the microphones almost transcribe themselves.
They transcribe themselves. Yeah, I'll take that.
I wonder if, is there a way that we could give it a deliberately difficult problem? So this is what speech sounds like to a hearing aid user in a busy environment.
Mm-hmm. Induction loop systems are solutions for assisted listening, providing access to high-quality intelligible sound for hard of hearing. These systems are a great benefit to the hard of hearing, and demand is rapidly increasing around the world. Assisted listening benefits a large and ever-growing section of society. Hearing impairment affects 1 in 7 of us, a number that is increasing as the population ages. Providing fair and high-quality service to this large group is becoming a high priority for any service provider or public organisation.
That's pretty much perfect, isn't it?
Almost.
I'm very impressed with that. Yeah, because I think this is the most impactful application of the technology is hearing impaired folks.
100%.
That was totally what we were focused on.
Yeah.
Yeah.
It's really exciting to see it being used in those kind of important ways.
That's so amazing. I wonder if I can find an example of crosstalk.
We're doing exactly what we talked about earlier, which is qualitatively testing a system.
Yeah, I know. Isn't it great? And the other thing, by the way, is I'm playing it out from the speaker of my iPad. And I've noticed experimentally, perhaps you have as well, that it's dramatically different from a voice in the room. So I don't know whether it's to do with some moire effect.
Something like that. Yeah, there's definitely an effect that hasn't been very well accounted for.
Yeah, because one thing we were trying to do for months is just come up with ways of doing automated testing. And so we got one of our staff members to read out a whole bunch of things, and we found out that the placement of the microphone, whether or not it was being played out from a speaker, what kind of speaker it was, just completely transformed the performance downstream. So it's almost impossible to test this stuff, basically.
I didn't realize how deep you've gone into this.
Yeah.
And paid a few taxes and lost $1 billion a year. You are Donald Trump's apprentice. Let me talk about this
Senator,
issue.
I think I'm still on my time.
Well, isn't this a discussion?
This is our open discussion.
Let's talk about the state of
let me interrupt you and finish my sentence if I can. While she was Secretary of State,
now I can weigh.
She had a private server.
I get to weigh in.
That was discovered to keep that pay-to-play process out of the reach of the public.
Pence,
because Hillary Clinton failed to renegotiate.
More American troops
Hillary
in Iraq.
Hillary Clinton failed to renegotiate a status of forces agreement.
No, that is incorrect.
And so we removed all of our troops from Iraq, and ISIS was able to be conjured up in that vacuum
But I'd like to correct.
and overrun vast areas of Iraq.
I have to say, I am bloody impressed with that. That is remarkable.
It's done okay there.
My congratulations to you.
Yeah, thanks.
Yeah, I mean, as a veteran user of ASR tech myself, I am bloody impressed with that. I want to use it.
Please use
Give me access to it.
But it's the crosstalk problem's still there, though. I mean,
yeah.
This
but
is the thing it's hard for humans, right? So
yeah,
at what point do you say, look, this part of the problem is AGI complete, and we're done? Let's just wait for that final system.
Yeah. Because the human brain has this remarkable ability to kind of compartmentalize. It's almost like we factorize the audio signal into these different components and we process them separately.
Yeah.
But it's amazing, just how well you can do without doing that.
Yeah, it can get a long way.
Yeah. Well done.
Yeah, thanks.
I love it. Ethics in speech recognition. What are your thoughts about that?
Very wide-ranging kind of topic, I guess. But I think ASR has not been in the limelight here. I think we've gotten away with not having too many practical, difficult decisions to make. We don't have to have a group of people red teaming our models, for example.
Isn't that ironic, though? Because speech data, from a biometric point of view, is very sensitive.
Yes.
It's arguably way more sensitive than the stuff people are putting up to ChatGPT.
Oh, yeah. So if we were doing voice identification and storing that, we'd have big questions to answer. We're not doing that. Yeah. So we've somewhat sidestepped that sort of whole area.
Yeah, and I guess the difference is as well that you throw away the customer data.
Yeah.
Whereas OpenAI, they seem to have almost redefined the boundaries of what's acceptable by boiling the frog. So at first, everyone was like, "Oh my God, you're storing the data. This is terrible." They didn't do anything about it, and now everyone's just slowly acclimatizing to it. But voice data does seem quite sensitive. And I guess this is why we're seeing the move to the client, the edge, where voice data is processed locally and then might not be sent up to the cloud. But we went through all of this with X-Ray. We checked, and the providers just throw the data away.
Yeah,
and that's why it's okay.
Yeah, and I like running stateless services, so it's great from a computer science point of view. But from an ethical point of view, it's a very simple kind of story. One of our selling points is we want to be like, the trusted, secure enterprise provider, and so going off and training on people's data is even if we have consent, it sends a particular signal, and my question would be, what do we actually need that to progress our systems forward? And historically, we haven't needed to do it, and so it makes it an easy decision because I really would like customers to not have to worry about this.
Yeah, it's a tough one because the reason why Google's so good is for this reason. They actually use the users as a feedback signal, and Bing doesn't work very well. And I used to make the same argument about OpenAI and Anthropic. So OpenAI are the incumbent, and they're doing the mechanical Turk steal the customer data update strategy. Anthropic don't do that. They say that even though in their terms of service they can use customer data, they don't and they haven't. And they're now the best. So maybe it's not that important after all. I don't know.
Yeah, well, they've clearly made it work. And I think, we similarly haven't felt too much pain from, we're already going down that route. So
yeah, interesting. Has anything else come up on that?
Well, we have the questions. One of the things that we want to do is understand every voice. This is our vision, it's our mission. We want to execute against that. We take it seriously. And part of that means that we want to recognize underrepresented people, be as inclusive as we can, whilst recognizing that the training distribution is not always going to cover everyone we'd love it to. And so, it's one of the reasons why we've pushed hard on self-supervised learning is we feel that we get a wider generalization on that front. And we started to measure that somewhat internally. But that's an interesting ethical question. It's like, to what extent are you just going to optimize purely for revenue? To what extent are you going to build a product that could be used by a really wide range of people? And so there's a tightrope to walk there.
Yeah, no, I wonder what the trade-off is. You remember there was that famous gender shades paper where Timnit Gebru, I think, showed that facial recognition didn't work very well for people of color. And even now with multilingual LLMs, they typically don't work as well, for the primary language. So the mainstay LLMs that people use, they work really well for English, and then they don't work, there's this kind of long tail. And there's always the question of, are you in any way kind of making a trade-off? So by diversifying and oversampling, low attribute classes, are you kind of reducing your headline performance on the main class? And is that a trade-off that you're thinking about?
Well, I don't quite have that same mental model. So, if you need more parameters to soak up a wider distribution, go add those parameters. It's more an issue of having that data in the first place, really.
So having the increased ambiguity of like more distributions doesn't affect the accuracy of the primary one?
Not massively. Okay. There are obviously going to be trade-offs there, but if you have the data, we can train larger models to soak up and learn how to handle it.
And in some cases, like a lot of languages are quite low resource and also like with low frequency classes, there might just not be much data there. So would you oversample or would you like synthetically generate it?
We haven't gone too far into synthetically generating stuff. I think that's something that we could consider more. But yeah, you would have to oversample and learn as much as you can from the paucity of data that you do have.
So why do all of the ASR companies say that their model is the best?
Well, first answer to that might be that they truly believe that's the case because they're in their own world of their own training and testing data. So it may well be that on their own data that is true. And really the only way out of that is to get third-party evaluation done. And hopefully that will be a bit more representative of a general, broader distribution over which to test. I think marketing maybe can take over as well and, do its thing with these numbers. In this field, in ASR and in others, I'd encourage people to look at third-party evaluation because the way that you evaluate and the data that you evaluate on makes a dramatic difference. If you consider collapsing words that have a hyphen or don't down into one entity, this can produce differences in your word error rate that are equivalent to like fairly large architectural gains that get published. So this is like very, very significant. And as you get more into the sort of the test set floor, as I would call it, these evaluation methods actually dominate the final result. So it's not just the data. You want that to be independent third party ideally, but the eval as well can just like really swing things. A language like English in ASR is very mature now. And so that method of evaluation really will dominate. And so, yeah, if you've got your own use case and you care about certain things and don't care about others, then go build your own sort of metrics, and that should be the way to go. But yeah, it is it's not a straightforward space. I mean, we've been doing this for 10 years and we've constantly been updating our ability to evaluate this well. And I still don't think we're there yet. So, I think about some of our customers, how on earth are they going to do a really good job at this? I'm not sure.
Yeah, I mean, we used to use a company called 3Play Media, I think, and they do a whole bunch of benchmarks across the ASR providers. What do you think about those third parties? And even with that, as you were saying, just the methodology they use is actually problematic for reasons that some of the customers won't understand, right?
There's a few things to think about. On the evaluation metric, you may be verbatim or not in ASR. So maybe your test set has things rendered in spoken form or written form. Maybe it's dropped all the filler words. Maybe it hasn't. So maybe it's in that cleaned up form or not. And I think this is one of the aspects that we hit up against is we produce a verbatim transcript. We want to be more verbatim. We want to have filler words. We want to have hesitations. We want to give users the option of whether it's in spoken or written form. So we want to just do things as correctly as possible, but sometimes that hits us on the benchmarks. But if you do a pure verbatim transcript, I think we back ourselves.
When I read I think there was like a state of ASR paper from 3Play Media, and they were comparing all of the transcription providers, and Whisper was on there. And, I think Whisper's pretty good, but out of all of the providers, it really suffered with hallucinations. So why is Whisper different?
I think there's a few reasons why. Number one, it's a supervised model that's been trained on data that contains artifacts that maybe we don't want to train on. The other thing is that it's end-to-end, which means that we're modeling the acoustics and the language in the same kind of space, and we sample, and sometimes that sampling can go wrong. And so we do have a little less control over what it's going to produce. So there's a big data problem there, but I think there's also in architecture something that's built in, and this is something that's also built into language models by design, large language models. So yeah, I think there's been some work to mitigate this, but yeah, we definitely see a different kind of picture on hallucinations with our setup, which we're quite happy with. But yeah, I think the data has played a big part there.
So I read the Whisper paper out in great interest when it came out, and they were quite bullish because they were basically saying, we're a bunch of guys and we train transformers, and we've trained a big transformer on, basically all of the, like the audio transcription paired data on the internet. They had to do a whole bunch of work to get transcriptions and to clean them up a little bit because, as you said, a lot of them are pretty noisy. But they were saying this is an end-to-end model, and because we've trained it on, was it 600,000 hours of audio, the first version, it does really good out-of-domain generalization, and everything in the world is good. What could possibly go wrong?
Yeah, I had some issues with that. So their OOD generalization wasn't really as good as claimed. So we ran it against our test sets, which definitely are not out there anywhere. And it wasn't generalizing in the ways that I think they claimed. So I was already very skeptical about this. I think it sort of speaks to a wider issue with supervised learning. I'm very much interested in the intelligence question, I think, as OpenAI are. But in my book, supervised learning is not even close to being on that path. To AGI, for example, you have to have that data to start with. If there's a problem with your model, you have to go and get somebody speaking it and the correct transcript. If you want to add a new word, you have to go and do that. And so there's a level of generalization that simply does not exist in supervised models. And some level of out-of-distribution generalization happening, but it's not as wide as is claimed. And certainly it's not sample efficient. And so, yes, I'm interested in building like really good products, high quality products, but also I'm interested in how can we build smarter machines. And you've got to think about the sample efficiency question there. And yeah, the sample efficiency is terrible for Whisper. I mean, this is like, it's great in many, many ways. Don't let me sort of like knock it too much. But it's not sample efficient. In order to train that English system, it has to use 100x more data than if you trained a self-supervised, unsupervised model and then trained a small supervised system on top of that. So, I thought it was a little bit ironic at the time because OpenAI should be pushing the big AI questions here. And actually, this is just a somewhat dumb supervised model that's very, very good at one thing, but doesn't possess that kind of like generality and generalization that I think we're shooting for.
Yeah, just help me understand. So my understanding is the Whisper model is self-supervised. Have I got that wrong?
Well, it will train on transcripts. So it needs transcripts.
Yeah.
So
hang on. How does the Whisper model work?
So it's like an encoder sort of decoder model.
Okay.
And so waveform in, encode it, and then you'll be then they set up like a multitask kind of decoding process where you it outputs a token that says what the kind of language is, and then optionally output timestamps in the word and so on, and just do a full kind of decoding process. So it's like sort of encoder decoder setup. But like the key for me is there's no self-supervised piece in there, and that's fine. You can get away with it to some extent with that, but you have to sort of make up for that with a large amount of data. And for some languages, that large amount of data simply doesn't exist. And to scale and deal with a long tail of issues, you're not going to get the data to go do that. And so it's okay, but it's like it's not got the kind of level of generality that I would like, or sample efficiency that lets you do better on other languages. Yeah, I mean, I've been a huge advocate for building unsupervised models and learning directly from data, and then using those models to give you the generalization power. And I believe that approach is scalable, with respect to the intelligence.
So you're a huge advocate of this kind of unsupervised approach. Sketch that out for me.
Yeah, so self-supervised learning in general is you want to set up some task where the data itself in some way defines the task for you. We've seen this across lots of different fields now. Kind of infilling, masking, predicting the future, corrupting the data, predicting the uncorrupted version from the corrupted version, and so on. These are all ways of learning from just directly from data, learning useful representations. I do see ASR as actually sort of the wider AGI question as a representation learning problem primarily. I think if you've got the right representation to operate over, you can do things very, very quickly. And so, this was one of the most amazing results that I've seen in my time at the company. About 4 or 5 years ago, we started introducing self-supervised models, and we got to the same loss on our ASR task with 100x less data after we inserted a self-supervised model that was trained on some prediction task. And this is like a wow moment. This is like so significant. You've just done 100x on that journey towards a more intelligent system. I think that's really significant. We haven't really gone beyond that since that point. And so I think we need more of those kind of moments, to be honest.
Whisper is self-supervised, or it's not?
Well, you could think of it as self-supervised, I suppose, on the language modeling part. So it's decoding to words, and you can do kind of a word level prediction. So it's, in some sense it's self-supervised, but really the core of the training is classic supervised. You have audio in, you're trying to produce a particular transcript, and so you need the paired data. I mean, that's the key.
Interesting. So what's the setup with Whisper then? So you have like a whole bunch of pairs of audio and text, and then you chunk it up, and then you put the audio in, and then it does a decode, and then based on some loss function, you update the weights in the decoder and the encoder. Yeah. Is that not self-supervised?
No, I mean, self-supervised would only have the audio data.
So you're saying the difference with your approach is that you have like a completely separate self-supervised process just for the audio, which is not paired with the text.
Correct.
Okay, and on their process kind of like conditions both of the encoder and the decoder on a single prediction task.
Yeah,
that's the difference. Okay, that makes sense.
Yeah.
Because it reminds me a little bit. Jan LeCun used to advocate for this approach. So there was a paper called Dino, where he would first train a self-supervised model, just on like visual representations, and even like showed you the representation space had far more information in it. And then when you go to kind of do a supervised, downstream task, the representation space will kind of sparsify, because it's like it only needs to know what it needs to know for that particular task. So you're throwing away all the other information.
Yep.
So you're kind of like keeping around more information in that audio model.
Yeah, that's right. That's right. And then, the idea is, the hope is you go train with just like 1 hour of data, really tiny supervised data set that can just pull out the right representations, and just maybe like learn that final clustering, if you like.
But you're applying a lot more kind of human designed architecture into this process. There are people who say the benefit of deep learning is that you could just go end to end and it's just magic. But you're saying actually in many cases it's better to kind of like decompose the problem into different modalities and subtasks and then put the whole thing together later.
Yeah. So the way that I would approach it is we want to do as much unsupervised learning as possible. We want to learn as rich representations of the world as possible, and then take as small a labeled data set as you can, and then go learn an API for your product. And in our case, that'll be training, a small supervised ASR system based on a fairly meaty unsupervised model. This gets you a level of generalization that you won't get with just supervised learning. Or you can get it, but you have to cover it. You have to cover it with a lot of data in the supervised case.
Yeah.
And that's the trade-off.
Yeah, because there was that Anthropic paper recently that on the Claude Sonnet model, it learned this representation space and you could get it to talk about the Golden Gate Bridge and stuff like that. It was really interesting that it seemed to find all of the categories that we talk about and we know.
Yeah.
But don't you have to put some priors in? I mean, it's almost like if it's completely unsupervised, if it's a complete blank slate, how does the model know, because it's like a clustering algorithm in a way, isn't it? It's kind of saying, this is really important, so I'm going to keep this around, and that's not important. How does the model know like what to hold on to and what to throw away?
Well, this is what gradient descent teaches it. So if you set up a task that's sufficiently difficult and has sufficient depth, so as it's learning, it can be learning increasingly more interesting things. This is what we have with LLMs. That next token prediction, it starts quite easy, but then as you've trained your model to just get a tiny improvement in your loss, you have to learn some world knowledge in order to improve it. And this is really good. So these are like tasks that in some sense have infinite depth. And it's like that with audio. You can go and set up a prediction task, and it's hard. And in order to improve that, you have to learn increasingly subtle things about the real world. And because you've trapped those representations, they're then available for you to use when you're training a supervised model on top.
Interesting. So are you talking about like an autoencoder?
Yeah, that's an example. I'm big on using time as a supervisory signal. I think time has a lot to offer us.
I'm a huge fan of time as well.
Yeah.
Yeah.
I got a lot of time for time. I think one of the big things that I want to advocate for is learning at multiple scales of granularity. And time, having a system that's in a certain state and is sort of faced with the world, it will get a signal at multiple sort of resolutions. So we'll get like a pixel level kind of supervisory signal. But then things are happening at the kind of the meta level, I guess, in our environment that happen and happen in sequence. And so there's a signal, there's like a very rich signal that's almost like hierarchical that's coming from the environment that we is there for us to exploit. And I don't think we've gotten going exploiting that yet properly.
So the features evolve with respect to time at different resolutions.
Yep.
So you could almost kind of like create a bunch of like time differences, turn those into features, and use that as part of, let's say, your autoencoder model.
Yes, you could. And I think this is almost like the next frontier for me, is removing the engineer from constructing the task. So you can model at a certain rate, 100 hertz, and you can learn interesting features. You can get Hubert-style tokens that are sort of these semantic tokens, representations of what's going on. They're at like 25 hertz. You can predict over those, and actually that's what people are using to build speech synthesis systems at the moment. So it's interesting. We've got these different components that are clocked at different rates. That they're all useful to come together because they're learning different things that are important. But the problem is that you have to have an ML engineer, ML researcher go and figure out that these resolutions are important, and this is exactly how we should set up the task. And so, that's kind of my next frontier that I see for self-supervised learning, is discovering these levels automatically and constructing prediction tasks, or having them emerge automatically, and so that we can predict over them and learn really efficiently.
Someone from OpenAI might say, don't do feature engineering. Why don't we just do a 3D convolutional neural network? So we take a spectrogram every 300 milliseconds, and then we just stack spectrograms over time, and we do a 3D CNN over it, and the system will auto-magically learn, like all of these different time dependencies at different, points in the spectrogram and so on. The alternative is to, impute some domain knowledge into that. So you're actually discretizing that 3D spectrogram, and you might have some log curve on there. So as the time horizon goes wider, you increase the coarseness. Maybe you increase the coarseness at a sort of like lower time horizon. So what's the trade-off between doing that yourself versus letting the neural network figure it out?
Well, if you're doing it yourself, you've probably got some application in mind, and you might be able to tune your way to victory there. And maybe there are certain applications where that makes sense. I think if we're interested in building increasingly general machines, we don't have time to do that. We don't have probably the knowledge to do that. And so ideally this would emerge naturally.
Yeah, so it's almost like creating a system that can meta-learn its parameterization.
Or even meta-learn its kind of the task on which it needs to predict. Feature engineering, there's this progression that's happened over the last 10 years. So, people used to say, okay, feature engineering, that was something that we did by hand. But now, okay, we have these stacked autoencoders that can go learn that for us. And then it's, okay, we can train this like end to end, and we have this like deep learning architecture. And we can automate that. We can have these kind of discrete program search to go look over all the different architectures that can produce a new one for us. And so that part of the ML engineer job has also disappeared. And now kind of we're scaling these architectures. So there's like a scaling piece that's kind of been solved. And, I see the bottleneck now as the task itself is the big bottleneck. We need to remove the ML engineer from defining the task in the first place. I mean, you have to put in some priors, obviously. There has to be some priors, but they can be quite weak, I think.
Yeah, I mean, it's just like what Francois Chollet says about developer-aware generalization. Mm-hmm. So, the system should generalize to a task that the developer of the system didn't know about.
That's what we need to get to. That's not much of what's been happening, I think.
So you're saying, I have this ridiculously high-dimensional space. The space is sparse. Actually, we don't need most of the information in there. So we're essentially designing a domain-specific compression algorithm that could generalize to any future downstream tasks that we don't yet know about.
Exactly. I mean, and this is kind of the idea of compression in general, is you need to decide what you're going to throw away and forget about, what abstractions you're going to hold on to.
Isn't there like an infinite set of abstractions? So as you say, it's really easy. If you know the downstream tasks, you can design the abstractions. That's a trivial problem. And then there's a whole spectrum of, okay, I don't know the downstream tasks. So is there some natural structure, to the compression algorithm that could generalize really well?
I think there always has to be some application in mind. And, you think about how humans do this. I think we have a lot of contact with our environment. We take actions. We get signal. And so there is some signal at some level here. So it's not completely, devoid of that. But there's also some, redundancy removal that can just be done in general. Classic compression almost. And then the rest of it has to be, I think, those abstractions need to be targeted towards a certain application at some point.
I mean, this is I spoke with Schmidhuber the other week, and he said intelligence is compression. But there's always a thing that, even from a Chollet point of view, intelligence is about something that happens in the moment. So in the moment, I create a skill program that generalizes really well for the particular task. So in the moment, you know what the task is, but we're talking about before the moment where you know what the task is.
And I think, these are the foundational representations that we need to support that kind of like dynamic on the fly program generation. And I see a big web of those representations that are missing from current systems that we need to go build.
Would you ever envision a system, because right now we're in the paradigm of frozen models. So we train a big model, we freeze it, and then we expect it to work in a multitude of different situations. And as we've just described, that in a way that's kind of broken, because like we're memorizing a distribution, and the system as a whole isn't intelligent because it's not dealing with novelty. So would there be future ASR systems that could kind of like adapt themselves, like maybe test time inference or something like that?
Yeah, I'd be a big advocate of that as well. This is what kind of, I think a lot of customers believe that AI solutions would do is, adapt and not be frozen. And maybe people outside of, the bubble that we're in don't realize that at all. But yeah, this is like feasible, and we should get there at some point. I'm not quite sure of the journey there, but having systems that can adapt to what you're saying and how you're saying it, the acoustics, and become much, much more dynamic is clearly beneficial.
Active inference, as Carl Friston calls it. I'm a huge fan of this idea. But then from a software engineering point of view, it becomes really challenging because it's the ultimate manifestation of what you said before, which is like, doing fine-tuning models, letting the customer fine-tune the models. But it's also really cool because, in a federated learning point of view, you can actually be feeding back some of these learnings into the Nexus. So you've got this like dynamic agential system. But how would you even test such a thing, and how would you roll such a thing out?
Yeah, I don't know. The thing is goes beyond beyond some of the things I've been thinking about. But federated learning is really interesting. Yeah, so maybe you have some core set of metrics that you're running against your central model to make sure that the updates from all of your local clients are not sort of disturbing the system performance. But as we were saying, if there's a level of qualitative eval that's required once these systems are so mature, that becomes a challenge.
I'm really interested in federated learning as well, especially because now increasingly we're getting phones and computers that have incredibly powerful GPUs on, and we're getting very good performance with quite small models. And even Apple did a thing where they have a big model in the cloud and they have a small model on your phone, and there's some kind of handoff between them. And figuring out the architecture and topology of that, I think, is quite an exciting future.
I mean, I think there'll be some level of distribution as we build more and more capable models. There'll be more interesting updates coming from different directions to help us improve and move forward.
What's the origin story of the company, and what's your background?
Yeah, so my background's in computer science. I wanted to get into machine learning around 2013 when there was beginnings of talk around deep learning, and that became a phrase, and I was very curious about what was going on there, so I wanted to get into that field. And so, yeah, I was due to do an MPhil at Cambridge, and I posted on Google Plus, of all places, is there anyone sort of offering any internships in Cambridge? And Tony Robinson, who's our founder, he responded. I was like, great, let's just go build some neural nets. And his name had just come up on a slide on one of Jeff Hinton's Coursera courses on neural nets, so I knew the name. So okay, this looks great. And then, yeah, we went straight into doing some work on scaling and recurrent neural network language models, which, it was having a really big impact on the speech recognition. And so, yeah, in those early days, we were doing some really exciting research, but it was translating straight into what was looking like quite an exciting product. And I really enjoyed that balance. I never did that master's and have just kind of stayed here since then and have helped scale our tech and the company as well.
Tony Robinson is an absolute legend. He was one of the early pioneers of, using deep learning in speech recognition, and of course one of the founders of Speechmatics. And completely unrelated to this, he actually gave me some some advice actually. So when we were building X-Ray, I think I met him on Facebook, and he reached out and he said, I'll spend an hour with you and I'll give you lots of advice about what you're doing and so on. Because he said that 20 years ago he tried to do something similar and the technology wasn't quite there yet, but obviously now it is. But he's a living legend.
Yeah, very much so.
Tell me more about it. I mean, how did you at the very early days? When he was building Speechmatics. I mean, what was it like?
Originally a distributed company, so I was working remotely, and I didn't enjoy that so much. So I moved down to Cambridge and basically started working in Tony's attic with a couple of computers under the desk, which was a lot of fun. And I remember we were writing some of our own ML frameworks at the time, and we were running some long runs on, it was a language model build, and I think it'd been running for 5 days. I hadn't implemented the checkpointing code in C++, which was a big error, a big sort of noob mistake. And one day Tony comes up with a tray of coffees, and then, he plugs in the kettle, and the machine just goes down. And I just, head in hands, lose the experiment, have to restart again. So it was all quite chaotic and sort of building our own server farms and things like this. So it felt like the real kind of startup experience in Cambridge, which was a lot of fun. We muddled through, we built some good models, and that's kind of how Speechmatics came about. It wasn't originally Speechmatics, it was more of just a research outfit. But it naturally evolved into that pretty quickly.
Yeah, and you said you were working in C++. I mean, obviously now we are spoiled with PyTorch and all of these high-level abstract frameworks for building deep learning models, and we can do checkpoints, and we got weights and biases, and we got all this kind of stuff. What was it like back then?
It was a lot more difficult to get performance out of the GPUs. So to be honest, when I started here, we started using CUDA, and that felt felt like a revolution from using OpenCL, which I was using previously. So I thought I had it easy, but the flexibility that you have with modern frameworks is amazing. I mean, it really has been one of the big drivers behind these sort of exponential gains and progress that we've seen in the field. I think a lot of maybe newcomers will take that for granted, but it wasn't always there. There were good frameworks. So there was Torch Lua and Theano and others that were very good and very clever, but you still had to be careful if you wanted to really push the GPUs hard. So we ended up writing some of our own custom CUDA-C code, and we optimized that by hand. And that was really what was needed to get the best systems at the time. Whereas you can get close to that now with a lot of the stuff that's off the shelf, which is amazing. I know there's a lot of work still on compilers to make that story better, but it's very, very nice now.
Yeah, because there's an interesting journey from at the beginning, you're just building a single model on a single GPU, and were you ahead of the curve on doing things like, distributed model training and stuff like that?
Yeah, we were doing multi-GPU training.
Yeah.
People talk about like fusing operators at the moment. That wasn't a thing because they were already pre-fused. I mean, you didn't defuse them or anything like that. You just wrote the kernels. And so, some of the things that I'm seeing as studying today, I was like, well, why exactly are we back to this? I mean, we have lots of flexibility with things like PyTorch, which is great. But in terms of writing a really efficient application, you could just go straight and do it. Particularly memory management as well. I'm not a massive fan of the sort of dynamic memory management and the caching allocator that you have in PyTorch. For a lot of the applications we have, you can just, if you know what you're doing, just go define your memory up front, do a little bit of memory management yourself, and be a lot more efficient. So in some ways, I've seen us kind of regress a little bit, or at least it feels like it. But the flexibility is just amazing these days, so I can't complain about that.
Yeah, it must be interesting because obviously from your perspective, you're hiring a bunch of, the best experts in the world at this. And it's actually good to have that flexibility because you have very bespoke requirements and you want to do it exactly as you want to do it. And even something like PyTorch, you might still grumble about because it doesn't quite do what you want it to do.
Yeah, no, exactly. We can make it do what we need it to do, though, which is the nice thing. So it can be extended in ways that are interesting.
So at the very beginning of your company history, you just had a handful of people and you kind of had access to a beefy machine and so on. What's it like now? How many people do you have working here, and what was the journey from there to now?
So the company's now 120 people. Engineering's about 55. Machine learning team's about half of that again at 22. So that's a big change for us. We were even bigger at one point. So we've gone through a bit of a roller coaster kind of journey as a company, and we've felt quite a lot of those growing pains. I think they're common to companies of our size. And I guess on the compute side, we've seen our kind of compute cluster kind of slowly build. We've kept lots of the old cards that we've had, and as long as they don't fry, we'll keep training things on them, which is great. There's lots of questions around culture, I think, around how you maintain some of that dynamism and energy from the early days, where people can just roll up their sleeves and get almost anything done. You have that feeling, whereas that feeling of coordinating and needing communication to be strong, you start to become very aware that that's the bottleneck now.
How's that panning out? Because like OpenAI as an example, at the beginning they wanted to save the world, and then they started making lots of money, selling to consumers and so on. Is it a similar thing here that, when the company grows, you start to become focused on, building out products and being quite commercially focused, and then, some of the original kind of like engineering pluckiness erodes over time? How have you countered that?
I've always wanted to make sure that there's a sort of core component that's looking at more fundamental questions. And that's more or less always been the case. And that will drive projects that are always sort of slightly longer term. So there will be a product roadmap that's like, I don't know, about 1 year long. But then you've got that eye on the sort of 18 month, 2 year, maybe 3 year kind of projects that are going to deliver a bit of a step change or a paradigm change. And, as far as I've been able, I've always pushed for us to maintain that, which has always been, it's been a bit of a struggle. And particularly when there are projects that are quite difficult to describe to the rest of the business. But we've always managed to keep some kind of allocated effort there, which I think has served us really well, actually, particularly in a field that's been changing a lot. I mean, if we just stuck around with some of the early approaches, we'd be dead in the water. So that mindset I think it's not just required in general, but particularly in machine learning, which has just been such a fast-moving field in the last 10 years.
I know, I was going to ask about that, because when you look at machine learning research, it feels like it's moving at a million miles an hour. And to build a company on this stuff, you need to sort of like take it to an insane level of engineering maturity. So there's always the trade-off between, do I allocate 20% of people, just trying out all of the latest models, or do I try and focus on polishing what I've already got?
So there has to always be some level of incremental work. But despite there being like a fire hose of activity on archive and people publishing an exponential number of papers in Europe and the rest, there is just a common core of important work to focus on, and that feels tractable actually. So I think as long as you do allocate a sufficient percentage to staying on top of that, you can walk that tightrope. It's very possible.
So you're based in Cambridge, which is really good for talent, because you can kind of siphon off all of the bright young students from Cambridge and so on. But you've said to me before that talent density is really important. So it's actually better to have fewer smarter people than to kind of have too many people. So what's your hiring process look like? What do you look for, and how is that happening at Speechmatics?
We've had real success with hiring interns straight out of university who are really hungry, really capable, and training them up and seeing them do great things. And we've done this multiple times over. Investing in a few like that is very rewarding, but it seems to be very good for progress and retaining institutional knowledge as well. So yeah, we will hire for that kind of general capability and flexibility, and maybe also generalist mindset. So I have this mental model. There's two types of people. There's people who have that very incremental mindset, and people who are kind of generalist and scrappy. And people really do neatly, in my mind, fall into these two categories. And so we'll push hard to find people who are generalists and who are scrappy and hungry and can make things happen. And that has served us very, very well.
What does generalist mean to you? Does it mean someone who's end-to-end in terms of they can build UIs and apps and they know the research, or is it someone who can kind of like understand the business requirements and the technology at the same time?
I think it's more on the computer science end of things. Yeah. So people who can, implement anything across the stack, really. And as far as machine learning goes, we've not really hired for machine learning speech recognition experience, which again I think has served us well. I think you can pick up speech recognition if you need to very, very quickly. There's no issue there. And as it's turned out over the last 10 years, general engineering ability has become more and more important. As systems have become more homogeneous, people are spending their time scaling transformers, doing distributed compute. So yeah, that's been another sort of driving force that's sort of worked well alongside, I think, how we've approached hiring.
Yeah, because it's quite interesting, as you say, that it's almost becoming about software engineering skills more than anything else, which is very important. But at some point, if you lean into that, there might be some other interesting things that you might be, potentially missing out on. But an instructive question, I think, is if an intern, sent you an email and said, "Will, I want to work at Speechmatics," what are the biggest signals for you?
An interesting set of projects.
Yeah.
Maybe what I've just said implies no experience, but I think having evidence that you've rolled your sleeves up on some real life projects, got things working, and have got to done on those projects is really impressive, probably more so than anything else. So that's one of the big indicators that I look out for.
Yeah, I completely agree. I mean, when I'm hiring engineers, that kind of self-directed autonomy and ambition is really important. So look at their GitHub. How active are they? How self-directed are they? Now, just on the software engineering fundamentals, I know that we share many of the same beliefs on this. So Will, a man after my own heart, has instigated a mono repo at Speechmatics. Tell me about that.
So this was a fairly big project in getting us over to a mono repo. I think things have just evolved quite naturally previously, and so we've got quite a complicated build process involving Debian packages and lots of individual repos, and the way that things are assembled was becoming quite painful. And I have this principle that if things move together, they should live together. Everything was moving at the same pace, and we essentially had a mono build, but it was it was distributed. So each of those components should have moved forward together, and they could have been compiled together, but we weren't getting any of the benefits of them moving forward independently. So it made sense to bring things together, and we did that. And it has really, really simplified our build. We can get to like a final architect like much, much quicker. Although we've had to up our maturity on the DevOps side of things. I think that's part of the trade-off that you go for with the mono repo. But that's been good for us. And so we're just like going down that kind of that journey and making the most of that now.
Yeah, I mean, it's a bit like your comment before that sometimes rather than focusing on, I want to do something now, you need to take a slightly longer term view.
Yeah.
And Google did this famously, but many people say that it's created a bureaucracy and it takes months to get your code checked in and so on because, they've got this wonderful, consistent code base. But you almost pay for it a little bit because you have to get things approved and you have to speak to product owners and code owners and stuff like that. So it's always a bit of a trade-off. How have you approached that operating model?
So I don't think we're operating at the scale where we've hit some of those kind of issues. So if you refactor a component and it's affecting like 10 downstream services, you've got to go and then deal with that refactor yourself. We're obviously not in that situation. But we've spent time on our CI pipelines to speed things up. We've had to back it with more compute. We're testing more frequently, so integration happens earlier when you do mono repos. Yeah, we've had to think a bit more seriously about that. But yeah, definitely seeing it pay off.
Will, this has been amazing. Thank you so much for coming on the show. I mean, do you have any take-home messages for the audience?
Yeah, well, first, thanks so much for having me, and it's been a really fun conversation. Really enjoyed it. I guess my one takeaway would be like beware supervised learning. We want to shoot for bigger, ambitious goals. Unsupervised learning is going to have to pull a heck of a lot more weight. And yeah, I'd encourage listeners to work on it and see how far we can push that paradigm.
Amazing. And where can people find out more about you?
Can find me on speechmatics.com or on LinkedIn. We'd love to connect with a whole bunch of people. It'd be great.
Amazing. Will, thank you so much.
Thank you.